problem from ordinary differential equation, and this is from the chapter Simultaneous Linear Differential Equation, and the problem is t into dx dt plus y, this is equal to 0, and t into dy dt plus x, this is equal to 0. We have to solve for the dependent variable x and y, and here only independent variable which is t. For this reason, the dependent variable is more than 1, but independent variable is 1 or less than 1, or less than 2. So for this differential equation is said to be simultaneous linear differential equation. Okay, let this is 1 and this is 2. Now we first differentiate the first equation with respect to the independent variable t. So we start from this step, differentiate 1 with respect to t, we get, okay, we get this is d dt of t dx dt plus dy dt, this is equal to 0, and from here we get this is t into d2x by dt2 plus this is dx dt plus dy dt, this is equal to 0. Now we multiply this equation by t, we get the result as t square into d2x by dt2 plus t into dx dt plus t into dy dt, this is equal to 0. Okay, now we put the value of t dy dt, this is equal to minus x from 2. Okay, so we put here t dy dt, this is equal to minus x, and getting the result as t square d2x dt2 plus t dx dt minus x, this is equal to 0. Here we using equation 2. Okay, now to solve this type of equation, we know that we must have to change the independent variable from t to another independent variable, and for this reason we put here t, this is equal to e to the power t. Okay, and from here we get t, this is equal to log t, and now from this relation we get dp by dt, this is equal to 1 by t. Now if we write dx dt, and this is given by d of x, where we say d, this is the operator d dt. Okay, and dx dt we can write this is dx dp into dp dt, and what is the value of dp dt? dp dt is 1 by t, so we get 1 by t into dx dt, right? And this relation gives, here we write this is dx, we let that d, this is equal to ddt, this is equal to 1 by t into dx dt, right? So we get t dx, this is equal to dx dp, and we write it d dash x, where d dash, this is the another operator, this is d dp. Okay, and also if we differentiate again this term with respect to t, we get the result as this is dx plus, and the second term is t into d2x, because this is d2x by dt2, and from the right side we get, this is given by d dt of dx dp, right? And this is d2x by dp2 into dp by dt, because we differentiate this term with respect to p, So we first write, if we write here or more accurately, then we get d dp of dx dp into, we write dp dt. Okay, and we write this is directly d2x by dp2, here we write, and this is dp dt. Now we put again the value of dp dt. Dp dt is given by 1 by t, so we get this is d dash square x into 1 by t, and the left hand side we get dx plus t d square x, and by multiplying t in the left side we get t dx into t square d square x, this is equal to d dash square x. Now we get t square into d square x, this is given by d dash square x minus t dx. Okay, and again we already get from this relation t dx is given by d dash square x minus d dash x. So we get the right side is d dash into d dash minus 1 into x, and the left side is t square into d square x. Okay, now we write our this differential equation with or in terms of differential operator, and getting the result as this is t square d square x plus t dx minus x, this is equal to 0. Now we put the value of t square x and t dx 1 by 1. We get this is d dash into d dash minus 1 x plus this term is given by d dash x minus x, this is equal to 0. So we get d dash square minus d dash plus d dash minus 1 into x, this is equal to 0. So we get the resulting equation, because this term cancel out, so we get d dash square minus 1 into x, this is equal to 0. So we get our differential equation in simplified form. Now we solve our this differential equation as usual manner. We know that auxiliary equation is given by this is m square minus 1 equal to 0. So the roots are m, this is equal to plus minus 1, and since the right side is 0, so this differential equation have no particular integral. So only the complementary function is the solution of this differential equation, and we directly write the solution is this is x equal to this is yc plus this is x, because here dependent variable is x, so x equal to xc plus xp. xc means complementary function and xp means 0. Now the complementary function we write from here, this is a into e to the power p plus b into e to the power minus p plus 0, because xp, this is particular integral, this is equal to 0, because right side is 0. So we get the value of x is this, and we write it in terms of p, because here the independent variable is p, we say here. Okay, now x equal to, we put the value of e to the power p, which is given by t, so a plus b into t to the power minus 1, so a t plus b by t, this is given by x. So we get the solution of x, or solution of one dependent variable. Now to find out the another dependent variable. Okay, how to find out another dependent variable? If we again solve this process to find the value of y, then we get also another value of y, but we get two arbitrary constant. Okay, c and d, like c and d. But if we take 4 arbitrary constant to solve this equation, then our solution is wrong. Okay, because here the derivative with respect to x is 1 times and derivative with respect to y is 1 times. So we must have to record only 2 arbitrary constant. Okay, and here we get already 2 arbitrary constant. So we cannot integrate here to solve this equation or to solve the value of y. Now how to find the value of y? We find the value of y if we differentiate this with respect to t, we get dx dt. This is given by a minus b by t square, right? Now multiply both sides by t, we get t dx dt. This is equal to at minus b by t. Okay, and it is clear from this differential equation, that is from 1 we get that. So from 1 we get that, we put the value of t dx dt here, we get the result at minus b by t plus y, this is equal to 0. So we get y, this is equal to b by t minus at. Okay, and we get the value of x here, this is named as a, and the value of b here, this is b. Okay, and a and b together represent the solution. Okay, very interesting and simple process to solve the simultaneous linear differential equation. Right? Thank you for watching.